math analyzers, let's chat a little bit about the sine function that we talked about and unraveled from the unit circle yesterday. Okay, so the sine function, what we did was we picked those specific coordinate points around the outside of the unit circle that matched up with our special angles from our special right triangles. So we knew those exact values of those coordinate points along the outside. And we took those y values of those coordinate points and we actually made them y values if the x value is the angle measure for sine. And we unraveled that and formed this pattern in an XY coordinate plane. And again, where Y is those Y values in the coordinates, but X is actually the angle measure in each of the spots around the circle. And if you take and you spread that out, you get what we call the sine curve. Okay, quadrant 1, quadrant 2, quadrant 3, quadrant 4. Well, now today, we're going to do that for cosine. So this time what we're going to do, and it seems a little confusing at first, but you have to remember what in your coordinate plane you're doing. You are taking the angle measure at each of the specific points around the unit circle, taking that as your x value. And then you're taking the cosine value of each of those coordinate points, the x value, and you're graphing that as your y in the coordinate plane here. And so we're going to look at how does that compare to how the sine curve looked. So the cosine curve will look different because the values of those coordinates are not exactly the same all the way around. Okay? So just to review, the main coordinates that we kind of use to help us throughout the rest of the circle. This time we need to be looking at cosine. So we need to be looking at the x values of each of these coordinates around the circle, okay? And where their matching degree measure is in our special angles around the unit circle. So like if we start with 0, right? This time it's going to be starting all the way up at 1. Okay, so this will look a little different right from the get-go, right? Then when we start at 1 and we head kind of down in x value, right, to radical 3 over 2, radical 2 over 2, 1/2 to 0. So this curve, when we look at it as y is our coordinates that I was just mentioning, will actually start high and head low and then dip back up because this is the end of the circle right here. So this guy's going to go kind of down and back up, a little bit more like a cup kind of look. Okay, so that's the spread that we're going to do here. All right, now, of course, the first thing I want to do is kind of match up those degree measures with our radian measures, right? So we start with 0, 0, and then 30 degrees is pi over 6 radians. 45 is pi over 4 radians. 60 is pi over 3 radians. And 90 degrees gets to pi over 2 radians. And now we're over that 1/2. So we're heading to 180 having 1 total pi radians, right? So now this next one, this is a 60-degree reference angle, which means 3 is its denominator. This is 2 pi over 3. This is a 45-degree reference angle, which means 4 is its denominator, and this is 3 pi over 4. And then this is a 30-degree reference angle, which means 6 is its denominator, and it's almost to 1 full, so 5 pi over 6. This repeats 180 just because we're heading down here, okay? But now 210 has the 30-degree reference angle, so that's, 6 as its denominator. And we're just over 1, so 7 pi over 6. Okay, then here's a 45-degree reference angle, so 4 is its denominator. And this is just over 1 again, so 5 pi over 4. and a 60-degree reference angle here. So 3 is its denominator, and we're just over 1. So 4 pi over 3 all the way to 3 pi over 2. This is 1.5 times around, right? 1 and then half, and then 60-degree reference angle, right? So we're over 3 again, and we're almost to 2 pi, right? We know 360 is 2 pi. So that would be 5 pi over 3. And 315, so that's a 45-degree reference angle. So we're over 4, and we're almost 2 pi, so that's 7 pi over 4. And then 330 is a 30-degree reference angle, so it's over 6. And we're almost at 2 pi, so it's 11 pi over 6. And that's how we get all the way around radian-wise. Now we just need to match up the x values from the coordinates as we go, right? And so, again, reminder, 1, radical 3 over 2, radical 2 over 2, 1 to 0. So let's just write those. Starting at 1, then radical 3 over 2. These actually head down in value. Radical 2 over 2, 1/2 to 0. And now what happens is these continue heading down until -1 is at 180, and that's the low point. So this low point is right in the middle of the graph. So -1/2, negative radical 2 over 2, negative radical 3 over 2. And just a reminder, here's quadrant 1. Here's quadrant 2. Quadrant 3. Quadrant 4. And what's the only other quadrant where cosine is positive? Quadrant 4. So we had gotten all the way down to -1. We have to circle back up. So then that's negative radical 3 over 2, negative radical 2 over 2, -1 to 0. This is that point, 0, -1. So we're at that 0 again. And now finally back positive. So 1/2, yep. Radical 2 over 2. And radical 3. Oh, duh. Sorry, guys. I forgot that I started this side at 180. So I just have everyone off by 1. Good thing I looked up and realized I was not going to make it to 360, right? And this guy is where your -1 starts. And then, of course, so we're down all the way at the bottom, negative radical 3 over 2, negative radical 2 over 2, -1/2 to 0 again. Now finally back to the positives, positive 1/2, positive radical 2 over 2, positive radical 3 over 2, all the way up to back to +1. Okay, so a different look as far as our cosine curve goes. It's just slightly different looking, enough that you can kind of recognize them when we're looking at these differences. Okay. So what we're going to do here is, of course, we're going to take these measures and we're going to put them out, spread them out the same way we had done sine in the previous lesson, so that we can see this different looking curve called the cosine curve. Okay. So this time it starts at 0, 1, and I'm just going to put the matching, this will be when we do this, our X and our Y, right? When we graph this down here, I'm going to put these matching ones so we have a good idea as to what we're looking at here. We're skipping the 45s because we're just going by 30s degree wise for now, just so I can fit things as I go across. And this is down to 0, and then we go negative for 2 quadrants down to -1 at 180. This is pi number of radians, right? And then back heading up to try and go back positive again. And I'm skipping my 45s, don't forget. Back to 0 and then positive to 1 again. Okay, so it's still that sign, it's still that curve, it's still that coming back, that cycle coming back around, but this time it just starting high, going low, and coming back high. Okay, so not starting at 0. So again, this is 0 radians, this is pi over 6 radians, pi over 3 radians, pi over 2 radians, 3 pi over, I'm wrong, 2 pi over 3. Knew I wanted my 3. Just needs to be denominator. This would be 5 pi over 6, all the way up to pi. Then we're back down, so 7 pi over 6, and 4 pi over 3, and down to 3 pi over 2, 1.5, and then back up the other way, so 5 pi over 3, 11 pi over 6, and 2 pi. Those are only those 30-degree markers as I go. Okay, so I'll just do 30-degree markers as I go right through here. So 30, 60, 90, 120, 150, 180. So there's your pi, right? Then 210, my bad, 240. Yeah, I'm counting right. 270, 3 pi over 2. 300, 330, 360. So this is where you get 2 pi all the way around. And what I'll do up here is I'll put my 1 here. So 3 up and then -3 down. So here's your 1/2. Just so you have a reference point, right? And this time, like I said, we start high. So we start here. And if you want to think of it this way, end here. In the middle is your low. Okay, in the middle is your low. So you're curving up and down. So 3 pi over 2. Well, let's get the 1/2 up here so we know right there. 3 pi over 2 is like here. And then 1/2. And then down to 90 is where your 0 is. 270 is your other 0. Now we jump down to 1/2. And then right here is radical 3 over 2. And then we've got the radical 3 over 2 matching over here. And the 1/2. And then back to 0. And then 1/2 and radical 3 over 2. And now we curve that sucker. So it does still need to be curved, right? As it is. It's a circle to spread out. And again, just starting at a different point, using that as your Y to spread out. Okay, so we're spreading that circle. This time using the X coordinates as we're spreading. And that's what we call the cosine curve. This is what we call the cosine curve. Okay, that's what it looks like. And again, it's the unwrapping of those X coordinates in the unit circle from place to place. Okay, and I did point out the quadrants as we went, and that's why cosine positive, quadrants 1 and 4, right? Just like with sine, it was quadrants 1 and 2, so that's where your high points are, and then low points where you're negative. All right. Well, now we'll do the 45s. So notice the last one, the last graph, I focused in on the 30s. Now I'll focus in on the 45s, which are kind of your quarters. If you think about it that way for radians, like think about your quarters in between for your radians. They're over the 4s, right? So this starts high, and then we go down to radical 2 over 2, and then 0. And then we're negative radical 2 over 2 to -1. Negative radical 2 over 2 to 0 again. So 90 and 270 are my zeros because those are where I'm touching the x-axis. Excuse me. That's when I'm touching the y-axis. I'm on the y at my 1s. And then here, positive radical 2 over 2, because we're in the fourth quadrant, and positive 1 again. So I'll start on this side, and my quarters, since I'm going by radian measure, are here, here, and here, right? So this is 90, this is 45, 90, 135, 180, 225, 275, or 270, 315, and 360. Okay. Starting high. So let me just do 1, up twice, -1, down twice, right? Do it that way. So there's your 1/2 in between. So start high. And remember, this is your 0. That's 90. Your low is 180. Back to 0 at 270. And then 2 pi is up high again. And your interim, right here, sorry. I wasn't thinking for a second. Okay, so my interims are these pi over 2. Okay, positive in quadrants 1 and 4, negative in quadrants 2 and 3. So this kind of divides it into each box is kind of your quadrant. And that makes it a little bit easier to think of them. I like these types of coordinate planes for trig, right? For trig functions that do the radians this way. Just makes things a little bit nicer to divide into quarters. And then, of course, if we're heading backwards the other direction, right, we go here, are our halves. And we still want to start and end high, right? And in the middle is still your low. And pi over 2 and negative pi over 2 and -3 pi over 2 are still your zeros. And so then it makes it pretty easy to figure out your radical 2 over 2s and connect curved. So it does look kind of like a cup or a chalice if you think of it that way. All right, you kind of think of those that way. And this is the cosine. Okay, so your angle measure is your x. Your output is where are we on the unit circle in your x coordinate. Okay, so where are we on the unit circle in your x coordinate? That actually ends up being your y value when you're spreading this out over the graph. It gets a little confusing when you have to think of it that way, but it is nice as far as cosine is so distinctive. Cosine looks like the cup, right? And sine looks like an S when it's on its side. Okay, so it does really help us remember which is which distinctively. Okay. And a quick sketch. So pi over 2, pi, 3 pi over 2, and 2 pi. And if you're doing the quick sketch, up, 0, down, 0, back up. This guy is your cup. Again, curve. Like that. Okay, so just being able to do the basic sketch or being able to do the more detailed graph. Okay, both important. But really, what's the important part between these two lessons, lesson 6 and lesson 7, is recognizing that distinct difference between sine and cosine. Okay, and what they really look like as we are unwrapping them. Okay, so let me just end with that. Making sure you see that very distinctive difference between who starts where, okay, and how they match up. Sine, cosine. And actually, you're probably looking at this thinking, they're just a little, save that thought for chapter 10. Okay, save that thought for chapter 10, that like slight, wait, could they match up if I just move something around? Yes, we're going to do it in chapter 10. So we're going to start taking these basic graphs and using them and seeing how they get spread out or narrow, or what is this distance that we're calling a cycle, and all that kind of stuff. So that's what we analyze next. But let's get this down first, right? Let's get the basic down first and just keep practicing this exact same basic graph for sine and cosine. All right. Looking forward to doing that with you very soon. I'll be seeing you guys. Bye.